Recent conversations about is TDD dead has led to a bunch of other conversations about the value of a hexagonal approach to Ruby on Rails architectures. I've had a number of interesting discussions about this, in particular with one of my colleagues, Badri, who is one of our most experienced developers at ThoughtWorks. He's had a lot of experience both with Rails and with other technology stacks. So these conversations are pretty interesting, so we thought we'd record them and talk a little bit about the role of hexagonal Rails architectures and broadly what that means for these kinds of broad stack development environments in general. In the first of these conversations, we talk about an introduction to what hexagonal Rails means, and then focus particularly on the attitude towards data storage. Do you use active record? Do you want something a bit more isolated?
We've been chatting about this topic off and on, the topic of hexagonal Rails, and when we want to be hexagonal or not. So I think the first thing to go into is what does it actually mean to be hexagonal Rails? So you follow the Rails community more closely than I do, so what's your take on hexagonal Rails?
So I guess to talk about hexagonal Rails, we have to first talk about what hexagonal architectures themselves are, and let's just talk about the Alistair Cockburn website, where he talks about what hexagonal architecture pattern is, and then there's quite a bit of discussion and commentary on it and how it applies to different applications and what are the concerns and trade-offs involved and things of that sort. So let's talk a little bit about that. So as mentioned on the Alistair Cockburn website, the idea of hexagonal architectures is that your domain model is a contained, self-contained entity in which any interaction with external elements and what constitutes internal and external is a part of deciding how the boundaries of your system are defined. Anything outside the boundary of your system and anything inside the boundary of your system have a particular directional order where things that are in outer layers depend on things that are in inner layers, but there isn't a dependency the other way around. In other words, your application does not have any dependency on what might be considered external to the application domain itself, whereas things from the outside can have a dependency on your application. The advantage this then has is you can have your domain model as a contained entity. You can run tests on it in isolation. You can explain its behavior in isolation from all these external components. So then the question becomes, what constitutes the inside and what constitutes the outside of your application, and where do you draw these boundaries? And if you then go and look at the articles that are there on Google, when you search for hexagonal Rails architecture, the kind of articles that come up seem to start out with the assumption that the database in a Rails application is on the outside. Now, interestingly, on the Alistair Cockburn website, he does mention the database as one of the things that could be on the outside, but I don't think that's a given. I don't think that is set in stone, saying any database that serves to persist your domain objects is by definition on the outside. I think that was just more meant to be, this is the sort of thing that typically lies on the outside in a lot of applications. And the Rails conversation starts out by saying your application database is on the outside, and I think that is where a lot of the confusion comes about. The hexagonal architecture, I guess, the website also talks about how your application could be drivable through a web interface or a command line interface or a test driver interface, and that isolating that aspect of your application and providing that as one of the boundaries then means that you can test your application independent of having to go through a web-based UI and still test the entire domain logic and behavior. Yeah.
Okay, so let's explore the database side thing first.
Okay.
I looked at the hexagonal architecture as really a kind of a twist on the traditional notion of a layered architecture. And the layered architecture is quite an old pattern. And the idea is you're dividing a system into layers where there are layers, the higher layers are able to see the lower layers, but not vice versa. Now, there's various ways in which people do layered architectures for enterprise applications like ours, but you typically see three broad layers that you like to work with, which I'll illustrate with these 3 books. So the upper layer here is typically the user interface layer. The middle layer is, which is this one in the middle, is the domain logic. And the bottom layer is data access, which could be databases, but also could be services, anywhere else where you want to get your data. And the thickness of the books doesn't imply anything about the size of the layers or anything. It's just what was on my bookshelf and easy to hand. So in a layered architecture, your UI can see your domain, but also your domain can see your data storage and data services. And that kind of makes sense, because if you want to do things with a domain, they often have to grab data. You're saying, get me the customer for this order, that kind of thing. But what that does is that couples your domain to your data store. So the hexagonal point of view tries to say, well, no, we want the domain to be the center of the universe, and everything else rotates around it in the usual hexagonal shape, which I'm not going to even attempt to do with only 2 hands. But if I was an Indian god and could sort of summon extra arms, that's what I'd do with it. Now, as I said, that means we have to think fairly carefully about the distinction of how the domain and the database fits together. Now, to grab another book as a prop, if we look at how I talked about this in this book, my patterns book from 10 years or so ago, I talked about a particular pattern called the data mapper pattern. And the data mapper's job is to break this layering construct and say, we want the domain to be independent of the database. And that involves a bunch of extra indirection and some faffing around, but it allows you to get to that point. As opposed to the default database pattern in Rails, which is, of course, active record, which the domain is very much tied to the database. So I want to explore this aspect of hexagonality a little bit further. Now, you, Badri, have worked in both styles, right? Because you've used data mappers a good bit, you've used active record a good bit. How would you characterize the differences between the 2?
So yeah, it is true. I mean, it's for the last 6 years or so that I've been doing Rails, 6-7 years that I've been doing Rails development, and prior to that, it was almost all traditional Java, the kind of 3-tier application that you're talking about. So and yes, almost all of those applications used a data mapper, and the data mapper was implemented with something like Hibernate, which gave you the ability to abstract away exactly which tables and how you were retrieving the data. And even that would then be hidden away under some sort of a repository or a data gateway through which you would then go and get these objects, and depending on the kind of data you were getting, the right data mapper would be invoked and the right mechanisms for loading the data would be invoked. It would then be fetched and then fed into your domain model. And having worked in those kinds of systems and having worked in Rails, I can tell you that there is a difference in the kind of applications you want to build with each of these sorts of patterns. The kind of applications that I did build in the Java world were very hairy, complex applications in domains where the number of if conditions would just boggle you. Primarily, every aspect of the domain was convoluted set of rules, all intended to somehow try and rationalize business rules that had been made up by human beings and created over decades, essentially. So trying to deal with a domain which has that sort of inherent complexity in it needed you to be able to model your objects, and your objects ended up having very rich interaction patterns with each other, and you needed to be able to model those interactions, test those objects, and you really did not want to be bothered with how that data was persisted and hydrated into your domain objects at the point where you were testing this really complex business logic. And in those kind of applications, I did find the data mapper really useful. Subsequent to that, where I've been working for the last 6-7 years now, is as a Rails developer within our product division, and our products are applications. They're not simple applications by any stretch of imagination, but the domain is not enormously complicated, like the domain of insurance or equipment leasing is in the business sense. The first application that I worked on in studios was one called Mingle, which was a project management tool, and it was essentially meant to let people manage their card backlogs, their work backlogs, and to present the information about the work that they're doing in a few different ways, such as being able to slice and dice a list of cards and show it on a grid view, like a card wall, and things of that sort. The interesting thing about that application was because of how ThoughtWorks believes that Agile projects should be run, we didn't mandate one prescribed process for everybody, which means people got to describe exactly what they wanted to track and how they wanted to track it in Mingle. And if you're familiar with applications like DabbleDB, you might see some parallels where you get to decide exactly the structure of the data you're storing. And in order to meet this, in the traditional enterprise world, which I'd worked in before this, you'd probably go with user-defined fields, and I think you mentioned user-defined fields in the POEA book as well, or you have mentioned it elsewhere. I think so. The traditional way for doing this is for every user-defined field, you'd have a one-to-many mapping, and for the object that contains all the user-defined fields, it would map to one-to-many defined fields, and you'd have to load all of them every time you wanted to talk about this object and analyze it. That's the traditional relational modeling of it. We found that this started hurting us really badly in the Rails world, and it wasn't necessarily the most performant way of doing it. So we actually did something that was pretty radical in Mingle. And it has stood the test of time. At that point, I was quite worried about whether it was a good idea, but in the past 6 years that we've been working with it, it has not caused any problems. And indeed, the Mingle system is more complex due to a number of other reasons, but not due to this reason. And what we decided to do in that case was we decided to dynamically alter the schema of the application. So when somebody said, I want to track another extra property, their card table, the card table for their project, would then get an additional column. And so we essentially tied our domain model very, very closely to the database, and this helped us get rid of the one-to-many mapping that we needed to do and the amount of data we needed to load from the database, and made a lot of things such as filtering, sorting, aggregating. All of those things became a lot easier with this sort of a data model.
Essentially, bringing the database right into the heart of the application.
Absolutely. Yep. So we did this thing where, while in the traditional hexagonal approach, one might think that the database was supposed to be kept on the outside and it had to interact with your application through a gateway and a mapper of some sort. We decided to bring the database right into the heart of the application so that we could get all these other benefits of being able to slice and dice and aggregate data very, very quickly. And that was a conscious decision, and that meant the database was no longer on the outside, and we didn't try to isolate ourselves from it. And in this, we were just assisted by Rails because the active record pattern maps very easily to tables of any arbitrary schema. It does all this internal reflection bit and automatically just wires up everything and gets you all the data you need in one go. We then had to build a domain model that could then interpret various kinds of data that could come back from the database, but that then became the complexity of the domain itself. It became a meta-model system, and the complexity in the system is the fact that we built a meta-model-based system, not in the fact that we were connected so deeply to the database. Right?
So there's a theme here in that when I looked at these patterns back when writing that book, I said the key reason to want to use the data mapper is when you want your domain, in-memory domain model and the database model to evolve independently.
Right.
And this is a case of where you're actually more than happy to have them in lockstep together. There's no reason for them to evolve independently.
Yeah, as a matter of fact, if they evolved independently, the application would crash and burn.
But your previous experience, you said the data mapper was a good pick, and that was because they did need to evolve.
Oh, yes. We were building applications on top of existing databases and existing schemas, and they weren't necessarily, these were not greenfield applications. When you're talking about an equipment leasing company, they've been leasing equipment for donkey's years. You can't necessarily just throw that data away. That data is still important. Your application needs to be able to work with that data and any new data that it generates. So we were necessarily constrained to using a lot of the data that they already had. the schemas were not completely under, well, individual schemas may be under our control to some extent, but by no means was the entire database under our control, and we weren't necessarily given control of all the tables in our schema either. Some tables would be free for us to write to. Some tables were meant for external systems to dump data into through batch processes on a nightly basis. So there were all these kinds of things, and the entire database was not completely in our control. And in that sort of a case, it made a lot of sense to isolate ourselves from things that could change under the application's control and things that were meant to change under the control of some other system. And you didn't want changes done by some other system to start impacting you adversely as far as possible. Now, even in those systems, I will admit, just because you had the gateway and the data mapper, it didn't mean you were isolated from the data layer. There were computations even in those sorts of applications that needed you to carefully think about your choice of aggregate routes, how you were going to pull up objects, because if you use the same transactional objects that were used to save data to the database, certain other analytical calculations, which needed to be done by a completely different set of users or a different role that used the application, would become incredibly complex, because 10 people could use a very small transactional fine-grained object to write 1 million rows over the course of 10 years into the database, but the person who needs to view the summation of what happened over the past 10 years as created by these people would end up needing to load millions of rows. So you would certainly not use the same set of objects. It would be the same data in the database, but you'd load them differently and you'd analyze them differently. So
Right.
even in those domain models, you needed to think carefully about how you were accessing your data. You weren't insulated from that.
Right. I mean, I've characterized it as when you're using the data mapper pattern, really what you're trying to do is you're trying to ignore the database as much as possible. You're treating the relational database like some crazy aunt. You shut her up in the attic, and you don't ever want to deal with her.
Yeah.
But the reality, of course, is that you can do a certain degree of isolation, and certainly
Right.
data mapper gets you a hell of a lot further down that path than other patterns, but it's never completely that way. I mean, there are always times you've got to take into account of how I'm going to access data, the sheer mechanics and the operational points of accessing the data are going to impact you. But they're going to impact you, say, 10% of the time, not 100% of the time. And
Exactly.
that's the value that the data mapper brings in.
Exactly. Exactly. Whereas once you've decided to have an application which is so closely tied to your database, and the schema of your database essentially drives the behavior of your application, like it started with Mingle, and the application is completely within the control, the database is completely within the control of the application. We created the tables, we created the relations in the database, and we maintained them, and we created all the data and were responsible for interpreting all the data in the database. It wasn't ever read by an external system, and the database was completely encapsulated by the application under question, and there was no data level integration that happened with any other system. So in that case, with Mingle, we felt completely free to bring the database in, and all our unit tests would hit the database as a part of running the application tests, and we had thousands of tests, and they would all hit the database. And the other interesting thing about Mingle was that it was also a shrink-wrapped application that people would download and install. Yes, it was a Rails application that was a shrink-wrapped application that people would download and install, and we gave people the option to connect either a MySQL database or a Postgres database or an Oracle database. And the only reason we were able to provide all these databases and switch between all of them and make sure the application worked in all these different situations was because our application's tests hit the database. If we knew at any point in time if a particular feature or the particular kind of SQL that was generated would break for a particular database or a particular database version, and we'd be able to fix that and adapt that and make a fix for it. If we were insulated completely from the database, that wouldn't have given us the level of confidence we needed in order to be able to switch from one database to the other. Because initially we started out with just Postgres and MySQL, and then eventually we added Oracle.
So that's interesting because, of course, a common reason that people say you want to do this kind of data mapper style isolation from the database is because you want to be able to switch databases. And it's the old joke that people always say that, but hardly anyone ever actually does it. In your case, not just did you not use the data mapper, you went directly with Active Record, you actually did switch databases, and it actually worked out better for you because of the way the whole testing went. I find that wonderfully amusing.
Yes, it is. It is a study in complete contrast to every theoretical argument that's put forth for isolating yourself from the database. I think a lot of people assume that just because you've got SQL as a standard and you emit a standard SQL from one layer of your application into a layer that's supposed to accept the standardized language called SQL and perform exactly one thing one way, that the world is hunky-dory. The world isn't hunky-dory, and you only realize it when you need to change your database. And at that point, my God, the kind of edge cases that you run into, you wonder why you went through all that pain anyway. So yeah, so we didn't go through that pain, and we were much better off for having all our tests hit the database. And even today, our tests run on multiple platforms. They run on multiple databases, operating systems, browser combinations, and yeah, we have a huge suite of tests, all of which hit the database.
So, but having said that, one good reason that I've heard you say for the data mapper is if you don't control the schema, or if you've got a typical situation where a database is being used as an integration database, a whole bunch of applications, that kind of situation pushes you towards a data mapper.
Yeah.
Something else you said earlier on is the complexity of the domain. And I would imagine that because as your domain logic gets more complicated, you want to structure your objects differently for computational purposes than you'd want to structure your storage. And so that causes you to want to vary the two models. So those are the two forces that push you towards a data mapper. But if you haven't got either of those two forces in play, then a simpler approach, such as Active Record, is more straightforward to work with. Would that summarize things?
Yeah, absolutely. Active Record is a much simpler way for working for domain models that don't have either of those two forcing functions. Active Record is a much simpler mental model that gives you the one-to-one translation between a data model and your domain objects. And if you're willing to work with that, and there are lots of domains that can work with that, and the simplicity of translation does not say anything about whether this application actually delivers enormous value to your users or not. It's just, the complexity of the domain has got very little to do with the value you deliver to your users. So you can build highly valuable applications that solve a lot of very important problems while still having a domain that is fundamentally quite simple. And
go ahead.
Go
on. So one factor to bring in there is this is not necessarily a factor of size, right? Because Mingle is, okay, it's not a humongous million-line of code app, but it's still pretty big, right? I mean, we're talking 100 tables or so, 50,000 lines of code, production size. I mean, it's not a tiny little application.
No, far from it. I mean, it's not a toy application by any stretch of the imagination. And in fact, I honestly think that it's a little too big for me to even keep inside my head at this point. But yes, it's certainly not a toy application. The number of static tables themselves, and that's the tables that come out of the box, is closer to the 100 mark. And then we create tables on the fly, and we create tables and extend them and shrink them on the fly as well. And that then on a busy Mingle installation with a large number of projects, you can have hundreds of tables. And we manage with Active Record just fine. And it's a big application with a large number of tables, and we manage just fine with that.
Right. So it's not size, it's the divergence of the model that's the factor. So another thing I want to bring out, you mentioned, and again this came up in the recent East TDD Dead conversations, your unit tests, as it were, hit the database. You don't go for the isolated style of unit tests or try to isolate out the database. And you've been happy with those tests hitting the database. I mean, how long are your test runs? I mean, how big of an impact is that?
So when we started out, so we started building Mingle in 2006, and that was roughly around the time the ideas or the notions around separating the database from Active Record started to take root in some parts of the Rails community.
Yeah, I remember a particular meeting at ThoughtWorks where that was discussed quite energetically between the Mingle team and the East Coast.
Yes, exactly. And frankly, having been on the East Coast project and having been on the Mingle team, I had been party to both sides of the conversation, and I didn't quite argue for it both ways, but I was perfectly happy having my tests hit the database while on both projects, and I never found the argument of separating the database from something like Active Record, whose primary purpose it was to mirror the database. So there's no point having a pattern whose primary purpose is to have one-to-one correspondence with a layer, and then cleave that correspondence in the middle, because then what does it have a one-to-one correspondence with? I just didn't see the point. It just did not strike me as a valuable abstraction to put into place. And I thought, well, I kept thinking maybe we'll get to a point where the complexity of the interactions of the domain with the database will get to a point where it will force our hand, but it hasn't forced our hand. As an application gets, as you evolve an application and it actually goes out into public and users start using it, a whole bunch of other things actually become a lot more important than whether your tests actually hit the database or not. There's a big bunch of problems. And I think some of this you alluded to in the conversation, the ECD direct conversation, the last version as well. Like, people use, once your application goes out into public, people use your application not only in ways that you couldn't even imagine, like they use it in things that you would think would be completely bananas ways of using your application. And they do, and you've got to find solutions to those problems, and those take priority, because at the end of the day, people are using your application and getting value from it, and you're not too badly off because you're hitting the database. So right. Our tests grew from when they were around a minute long to the point about 2 years later when they were about 12 minutes long, our unit test suite I'm talking about. And this was a goodly number of tests, about 2,500 tests at that point in time. And since then, they've only been growing, and I think they've doubled in size since then, and they are roughly around 20 minutes right now, and I think they're about 18 minutes right now, and they run across both MySQL and, sorry, not MySQL, Oracle and Postgres, because those are two supported platforms at this point still. And yeah, over time, we were able to parallelize them. They used to run in one sequential suite. As soon as it crept beyond the 10-minute point, we started parallelizing them. All tests from A to G would go in one suite, and all tests from H to Z would go into another suite. And by starting to split that across and just throwing a little bit more hardware at the problem, we were able to keep our test suite within a completely manageable limit and continue developing without any problems to the level or quality of feedback that we received from our tests.
So you operate with I use the term commit suite to mean the tests you want to run to be able to have a commit that you can push into mainline. Mm-hmm. So you run with a 10-minute, roughly 10-minute long. Roughly
10-minute commit suite. Yeah, there are two separate builds. There's the commit suite, which runs on a what we call a pre-commit build. It doesn't, so you can push right to a Git repository right there, and that runs your pre-commit suite, and that takes very little time. And then once that passes, you can then push to mainline. So you get the benefit of the really quick test that you don't have to mess around with trunk. And you don't have to push a breaking suite to trunk and then break it for everybody else. You get to test it first, and that tells you whether it's good to go or not, and then you push it to trunk. And we do trunk-based development. Nobody keeps a local branch running for ages, but you have the opportunity to push to another repository, make sure it's good, and then push to another. At that point, you know that it's not your changes, it's only your integration with somebody else that's breaking, and that then narrows down the focus of any fixes that you might need to do as well.
Right.
Yeah, so we have managed to consistently work with around 10-minute test suite. And anytime it creeps up beyond that point, discomfort sets in naturally with the team, and they find some way to break it down and make it faster. And that number has somehow stayed the same. Like roughly around 8 to 10 minutes is when people start getting shifty and fidgety. It's one thing to shift to another browser tab and read something for 10 minutes, but it's another thing if you feel like you need to get up from your desk and walk away, because that then really breaks the momentum. So hopefully by the time it gets to that point where it starts getting really annoying and you feel like you want to walk away from your desk, which breaks momentum, we bring down the test time so that we can continue to keep flow.
Right. Okay, so I think we've fairly well done to death the pure data storage issues there.
Yeah.
So I wanted to back up a little bit now and talk about another aspect of the hexagonal Rails notion, which I think of as the attitude people have towards how they want to relate to Rails.
At that point, we'll leave off the conversation and come back to it in a future video.